Thank you for joining us today as IntelliMagic shares practical strategies for optimizing data storage in HPE 3PAR environments. We will be polling you, our audience, during the webinar. You will see these polls on the GoToMeeting screen, where you can click and provide us with your responses. We will share the data of the poll results immediately after each one, so be sure to make your choices promptly. Again, we will answer all questions at the end of the presentation. Today is Brett Allison, who is a Director of Technical Services at IntelliMagic. Prior to joining IntelliMagic in 2010, Brett spent his career in various technical and leadership roles, focused on infrastructure and application performance and scalability. At IntelliMagic, he leads the technical services team in the Americas. He delights in helping our customers realize value from using IntelliMagic solutions to gain operational efficiencies and reduce risk in their SAN infrastructures. Brett, I will pass it to you now.
All right. Thanks, Anthony. I'm going to share my screen and go ahead and get started. At this point, Anthony, can you see the screen?
Absolutely. We are live.
Okay. All right. So my name is Brett Allison, and today I'm going to talk to you about some practical strategies for optimizing your 3PAR storage environment. No matter what I'm doing, I try to be practical and pragmatic. Folks that purchase the 3PAR storage systems tend to also be very practical as well. They want the most bang for their buck. And my hope for this webinar is that you get some practical information on how to manage your 3PAR environment. The objectives of this presentation are to help users understand how to approach, manage, and optimize performance in a 3PAR environment by taking a look at several real-life examples. But first, let's look at the 3PAR architecture. The 3PAR storage system provides enterprise-class performance and features at mid-range pricing. You can acquire it in up to 8 nodes, and each of these nodes uses multi-purpose fiber channel ports to connect to host and disk. The nodes also contain control cache, data cache, and quad-core Intel processors. There's actually 2 specialized ASICs used for data movement and cache management, and the cache memory is designed to scale with the nodes, and a high-speed interconnect is used for connecting the cache and the data, keeping 2 copies of data at all times and ensuring there's no data loss. In these next couple of slides, I want to discuss the volume management and the AO policies. The way that the volume management works is that you'll actually have SSDs, fiber channel, and nearline drives if you have a multi-tier system. And within those are going to be carved up into little chunklets. Those are 1 gigabyte mini disks, if you can think about them like mini disks, and those chunklets are grouped together to form logical disks that are either SSD logical disks, fiber channel, or nearline. And then the logical disks get grouped together in what's called a common provisioning group, or CPG, for the purpose of provisioning storage. From the CPGs, the virtual volumes are addressable to a host, and they're either going to be tiered, meaning they reside on excuse me, more than 1 tier, or non-tiered, meaning they're pinned to a particular tier. So let's take a look at the AO policy, or adaptive optimization, as HB calls it. This is HP 3PAR's auto-tiering technology. Let's take the case of that we're looking at, where we have 3 CPGs, CPG underscore SSD, CPG underscore FC, and CPG underscore NL. Excuse me. Let's take a look at the policies. We have a gold, which is set to use SSD and fiber channel with a mode of performance. This is going to instruct the AO to promote as much activity as possible to the SSD tier. In the case of the silver policy, we have a balanced mode, and this is specifying that AO spreads the IOs evenly across the CPGs within that AO policy based on the capabilities of the drives and the space available. And then we have a bronze AO policy, which we have set to cost. And in this case, we have fiber channel and nearline drives. What we're doing when we set it to cost is we're saying AO policy, please put as much stuff on the cheap drives. There's also some other things that you can do to influence the way that AO behaves. And one of those is the capacity warning limit. So if the amount of space consumed in a tier exceeds the warning limit, then AO will attempt to move regions from the full tier to any other tier with free space. So that's just a little bit of background. Now we're going to go ahead and talk about the cases. Let's apply some of the knowledge that we obtained to look at some real-world cases. And we're going to look at, do I have enough HP? That's a play on words. Obviously, could be in horsepower. In this case, we mean Hewlett-Packard. Also, we're going to take a look at just optimizing AO, how to see if AO is working the way we want it to. And then we're going to look at the cost of actually implementing AO or optimization and look at a system that had some side effects from that. And then we're going to look at just real simple, basic detecting imbalances and understanding trends. So the last two are very simple. If we have time, I'm going to go through them. Otherwise, they'll just be included in the recording. But I will for sure get through the first three. All right. At this time, we're going to do a poll. So Anthony, Anthony, are you able to run the poll? Do you need me to do something?
The poll is live right now. Maybe
okay.
you may not be seeing, but it's on their screen.
Yeah, I don't see it as a panelist or as a presenter.
All right, the first poll is complete. And I'm going to show you the results. We show 94% said yes, that they have a multi-tiered environment, and 6% said no.
Okay, great. All right, so the first case I'm going to look at is a very simple case. And this was actually a picture from this summer. My family went on a vacation, and we strapped on the fuel on top of the car and loaded it up. Now this is a funny picture, but the idea is that we really want to make sure we have enough horsepower to perform the job. So in the case of infrastructure, we want to make sure that the infrastructure we have, in this case the ThreePart systems, have enough horsepower to handle whatever new load we might be putting on them. So if you're in a real fast-growing environment, that may be something that's more applicable. If you have a real stable environment and things are good, then that may be harder to wrap your mind around. So the first thing that we're going to do here, I just want to show you a bubble chart, and this is really summarizing the key performance indicators. We're showing the read and write throughput, the overall front-end response time, the front-end read response time, and we're doing this for a couple different systems. The blue dots represent relative I/O busyness. The green dots represent areas of low availability risk, and yellow dots represent some availability risk, and red indicates lots of availability risk. We don't have any red on this chart. The only thing we have is a little bit of red on the response time. The thresholds that we use are determined based on various modeling techniques to provide a sensible starting point based on the storage configuration and the workloads. And so in this case, we're just going to look at this system that ends in 5, and we're going to take a look at the throughput for this particular system. So this chart that we're looking at is a throughput for this overall for this system, and we see that the average, or that we see that the background colors represent the different thresholds. So we have a lighter area at the bottom, and that's actually the area where we have plenty of room for additional throughput. That light brown area above it is actually the warning, and if we had a busy enough system, we would actually see the exception area, but that's not shown in this. What this is showing, if I look in that, there's a number to the right of in the legend to the right of the system name. It's 0.01. That's just saying that 1% of the time we exceeded the threshold. So I'm not real concerned about that. I've got a green around it, and basically the idea here is this system has plenty of performance bandwidth or throughput capabilities. But I think what's interesting is we're able to tell you how close you are to the edge, and I want to show you how we do that. We actually have, if you look at this first line in this screen, we have the data rate, and that has an early warning of 2,000 and a performance exception set to 3,000. We also have some thresholds for each of the fiber channel ports. and those are set to 320 and 480. And so what we actually do is we inspect the configuration and look at how many ports we have, and we take the number of ports times the thresholds per port, and that gives you the aggregate. If that aggregate is the lower than what we have for the DSS rating, we'll use that aggregate number. So just real quickly, to know if you have enough, you really need to know what the controller is capable of. And we take over 20 years of modeling experience, modeling storage controllers, and we look at your configuration and we understand if there are how many adapters, how many ports you have configured, and we set thresholds appropriately based on the model and the configuration. In this case, they had plenty of HP. So just a real quick look at that. The next, we're going to go ahead and go to the next case. And so, Anthony, there's a poll here.
There's actually two polls back to back, and so I'm going to launch the first one here.
Okay.
The question is, have you observed impact on front-end ports during AO policy migrations? We'd ask you now to select your answer. And we've got votes coming in. All right. So the answers so far show that yes, they do observe impact is 24%, no, 76%. The second poll on this one is, do you have tools to view the impact? Go ahead and put your poll result in there, answer that question. We have votes coming in. And it looks like the answer is yes, 29% have the tools to view it, but 71% do not.
Okay. All right. I'm ready to get started in the next one. I'm going to look at the optimizing AO. So, Anthony, I'm assuming my screen is back showing.
You sure are. You're live.
So, you know, I like to think of this as suboptimal configuration. We're going to show you suboptimal and then an optimal configuration according to Dr. Evil. So ideally, when you're running auto-tiering, you will place all the important stuff on the fastest drives, and everyone will get really great response time at a really low cost, and they'll all want to be your friend and take you out for dinner. Sometimes, though, if you're not careful, you can get too many IOPS on the same tier. And this can happen when either there's insufficient disk space for a single type of disk, or when the policies are not configured to take advantage of either the higher tier SSDs or the lower tier nearline. And this can be a combination of your workload and the policies just not quite jiving. In this case study, we're going to look at a suboptimal configuration. In this next screen, I'm actually going to show you some balance charts, and I'll explain those when I get to them. But what I want to show in this chart is, you know, if you think about your different tiers, let's say this first tier is the SSD I/O capacity, and on average you could do, let's just say 500 IOPS per second per SSD. And then you have on your 10Ks, you could do maybe 100 IOPS, and on your SATA you could do maybe like 80 or something, or 150 on the 10Ks and 100 on the SATA or the nearline. Now, if you're only running at 20% performance capacity on your SSDs, you know, you're not really taking advantage of those very well. You'd want to use more. So the idea is to be able to understand the relative busyness of each tier, and that's what we're going to look at. So in this case, we have a balance chart based on the drive read I/O rate, and we have two different controllers. The controller on the right side is represented with an _5. That's its name is Monotis _2849_5. And what we're looking at here is an average, which is the green dot, the 10th and the 90th percentile, which is the green rectangle, and then the minimum and maximum in the yellow rectangular area. And so what these do, these are representing kind of a quick statistical view of the controller, how well balanced the read IOs are on that controller. The more variance, the more the wider the min-max, and the bigger the standard, or the 10th to 90th is, the bigger the variance. So we'll drill down here and look at the individual disk drive groupings. Okay, so we looked at this system, and what we saw was that the fiber channel drives, which are each bar now represents a drive, and you can see they're kind of grouped into the different drive types. The drives on the left are the 450s. When we first looked at them, they were totally hammered. The drives in the middle are the SSDs, and the drives on the right are so obviously not getting the best bang for the buck on our SSDs, and anyone having to access the 450s on read misses is going to get impacted in terms of response time. So this was not ideal. So what we ended up doing is we ended up going to the AO policy, and we tweaked the AO policy to limit the fiber channel capacity. We also did something that I didn't really talk about much before, but we enabled some of the SSDs to use adaptive flash cache. And this is what happened after we did that. We now were able to move the SSD drives to be the busiest drives, they're over on the left, and increase their overall average significantly while reducing the 450s to a reasonable number. And then the nearlines, we took some of the work from the nearlines and put on the SSDs through the adaptive flash cache movement. So in just a couple slides, we were able to see how that imbalance went to be balanced. This is just looking at the picture comparing the two side to side, which is something that we can do within Vision. You can compare any two charts for any different periods of time. And you just kind of see, it's real nice to see that those SSD drives move from that center band to the left side of the chart area. So in summary, the SSD drives were not really being driven. The 10Ks, 450s were being hammered. So we made two changes. We changed the AO policy to limit the capacity in the 450s, and we also set aside some of the SSD capacity for adaptive flash cache. And what we saw was that the busiest drives changed to the SSD drives. And it was really easy to see those change, identify the issue, and make the changes. All right, Anthony, we're at another poll.
The question here is number 5. Do you have a scientific approach to view the capabilities of your hardware in relationship to your workload? Go ahead and respond now in the polling software right there on your screens. We have votes coming in. Give it a couple more seconds. All right. The results here show that 25% say they have a scientific approach to view the capabilities of their hardware in relationship to the workload, but 75% do not.
Okay,
and it's back to you.
All right. So one of the things that you'll often hear from salespeople is that it's totally free. So you've at least run across someone in your life that said it's totally free. There's always a cost, though. We know that. We've been around long enough. Everything has a cost. There's a trade-off. You know, if you want to optimize, there's overhead to optimize. So optimizing it in the case of adaptive optimization means moving chunks from one set of disks to another set of disks. And that takes resources, right? You can't just, it's not free. And so we'll just look at a case where we observe that. So this is similar, this dashboard that we looked at earlier, and I'm highlighting the front-end read response time that's in yellow for the system ending in _5. We're going to drill down to this over time, and we see from 5 to 7 p.m., we see this increase in response time. And basically, I've got a number here that says 13 or 0.13. That's about 13% of the time I exceeded my warning. And you can see when I did that was in these intervals here. And you know, it's not at this point saying, hey, you have this huge problem, but it is saying there's a warning. During that period, response time was not great. So we want to drill down, and so I'm just going to click and drill down to the AO policies. And I know we're in slides, but I'm basically, as I click through, I'm clicking through the UI. And so I've drilled down here to the AO policy level. And the rating is actually higher because it's applying the same thresholds, but only to a subset of the data that's having the issue. In this case, the rating for the AO policy base_ESX_AO is 0.56, as you can see. The red line, the DBAO, it's not having any issues. It's performing really well. So I'm going to click and drill down, and that's going to take me to the volumes that are part of that AO policy. And these are the top 30 volumes for that AO policy. And I can see this big spike here up to like 18 milliseconds for a volume named WRHQ192_A_FCOD. Now, some of you may be going, what the heck is going on with these volume names? This is just an artifact of our anonymization process, so bear with me. So now we're going to take a look. I want to look at the throughput for the volumes, for the top 30 volumes for that AO policy. And what I see is clearly this volume, WRHQ-A-FCOD, is the busiest volume. So it's, again, if it's the busiest volume on the front-end perspective, from a host perspective, and there's something going on in the system at that time, it's going to be the most impacted. So that just follows. So I'm going to go ahead and I'm going to click down and drill down to look at that volume in a little bit more detail and understand the host that is associated with it. And the host name is GZGM499. And one other thing to really take in here is I've got the CPGs listed here, and I've got the allocations on those CPGs for that particular volume. And I see that this is a volume that is utilizing almost 8 terabytes of data, of which over 6 terabytes is on the 450s and just a little bit is on the 900s. And so we would expect during times when it's getting read misses, lots of read misses maybe, that it's going to have the response time of those back-end drives. But something else seems to be going on here too. So I want to look at the front-end ports. And so in this case, I'm looking at the front-end ports, and I see these 3, there's actually 4 ports. It's hard to see which ones, but I'm going to take a look at the throughput of these 4 ports by just drilling down on them. And I see that the throughput, there's nothing crazy, but I do see those throughput peaking at around 330 megs. Now, is 330 megs something that would cause an 8 gig port to be constrained? Well, I've got 4 separate 8 gig ports. I'm only running at about 330 megs, so I'm not getting anywhere near the performance capabilities of the bandwidth on those front-end ports. And that's indicated by the green rectangle around this chart. So I know from looking at this chart that that the throughput on these ports is not a problem. And just look, if I drill down to the associated volumes, once again I see this WRHQ192. So this volume is pushing most of the load on those ports. It's responsible for most of the load, but there's no front-end issue there. Yet we're seeing high front-end response time on the ports. Now, if I look at the back end is, there's no spike from 5 to 7, and the response time is very low. So in this case, we know that the volume response time correlated very closely to the overall front-end response time. We know that the back-end drives are not saturated. We know that the front-end ports are not saturated. So what we ended up doing is we ended up looking at the AO policy schedule. The AO policy happened to be scheduled at 5 p.m. every day. And when we moved the AO policy schedule to a later time, it followed. The response time increase followed. So this was a case where the internal system workload impacted the front-end user response time. So just to summarize, when you are looking at implementing AO policy, you want to see, it's not always going to have impact, but you want to see if there is impact on the front end. Then you want to make sure that you're scheduling those migrations during a period that won't impact online users. So conclusion, nothing is free. All right, Anthony, we have another poll.
We do. This poll is, do you have imbalances in your HP environment? Let's go ahead and open this poll. Go ahead and vote now. We have some votes coming in. Just a couple more seconds and I'll close the poll out. Last chance. And there's a few more coming in. All right. The results show 24% say that some imbalances are known, 71% say they don't know, and 6% reported no imbalances. Back to you, Brett.
Okay. All right, great, thanks. So not all imbalances are bad, but obviously there's some that are potentially disastrous. If, for example, if this truck keeps moving forward without a serious correction, it's going to tip over. A lot of systems are inadvertently put in production with imbalances. And while an imbalance will probably not tip over a system, it's important to know if they exist, as they can limit the system throughput. In this demo, I'm going to just show you a case study where we identify some front-end imbalances and look at what we might do. And the next screen, I'm going to show you how well-balanced the ThreePart front-end ports are. And this is similar to the chart that we saw earlier. The chart on the left shows a little bit more variance, so that means that there's a little bit more imbalance on the left because that rectangle, that yellow rectangle, is bigger. So we're going to go ahead and drill down on that guy. And in looking at its ports, I've got 4 ports on the left side that are busier than the other ports. Now, it's significant in terms of the difference. You know, we've got ports that are doing on the left almost 200 megs a second, and then I've got ports in that right set that are just doing under 30 megs a second. So there is some pretty significant imbalance. But let's look at the port speed. And it's a little grainy, but I tried to blow it up. This port speed is actually 8 gigabits per second. So we're only running at about 25% of the port bandwidth, even at the peaks. So we're probably not too worried about fixing this imbalance. And really, you know, what we want to make sure is, and what I want to think through here is just the process for rebalancing workload. So let's look at what we might do if we wanted to reorder or rebalance the workload on the busier ports. Let's take a look at the port or the volume associated to these ports. So I'm looking at one of these ports that is really busy, and I'm looking at the throughput for the volumes that are associated to those ports. And if I drill down and look at the busiest volumes on these, it's a host that's UGK-AA796. So most of the workload is being performed by a single host. So basically, and this is looking at the workload for all volumes, and I used a filter that contained that host name, and it's basically all of the workload is one host. So you can see the workload on these ports, and you can see what host it's associated with. The only way to reduce the amount of throughput to these ports is to actually spread the host across additional ports, but that would not be easy because it would require additional host ports, and it might not be real practical. What you can do is, if you do have hosts that are smaller workloads on ports that are busy, you can take smaller workloads and migrate them to lesser busy ports, basically going through and reconfiguring the zoning and masking to point them to see their LUNs on different ports. So there is a way to do that. It wouldn't be practical in this case, nor would it be warranted. But you should keep monitoring these ports to make sure that they're not reaching their limits, and so that response times are not impacted. So in conclusion, utilizing the balance charts is a great way to see if the ports are balanced or imbalanced. You can do that for any component on the controller, but the front end is a really good place to start. And then you can look, when you're doing that, and see if the ports are saturated. If they are, then, or close, if they're hitting maybe 50% busy, then you're going to want to look at the volume or system workload that's going through those ports and making migration plans as necessary. All right, we have one last poll, Anthony.
We do, and I'm posting it now. The question is, do you have a way to trend performance or capacity? The poll is open. Go ahead and answer now. Do you have a way to trend performance or capacity? Got our votes coming in. Going to leave it up just a few more seconds. It's your chance to get your vote in. There we go. Closing the poll. Our results show that some trending is 23%, no or manual trending is 62%, and automated is only 15%. Back to you, Brett.
All right. Thank you. So it sounds from the poll that there's maybe some room for improvement here. Not all trends are bad, but obviously some are terrible. I'm not sure if this particular fashion trend hit your neck of the woods at any point, but I think it's a pretty funny picture just talking about trends. The same thing goes for system trends. You know, some system trends are okay. Some trends are not so good. Things like increasing throughput and increasing response times. And so in this next screen, I'm going to show you some trending charts for what we call host clusters. And they're just groups of servers that share storage. We aggregate those for both performance and capacity in a single non-overlapping entity called a cluster. And so let's take a look at that. We've got a cluster view here, and we're looking at it over time, several weeks of data. And it does look like the cluster GZGM499, which has come up in some of our other case studies, is trending upward. Now, it isn't necessarily having the highest rating. It's at 0.41, but it is having the highest peak. So we're just going to go ahead and drill down on that and look at its volumes. And so when I isolate that particular volume or that particular host, I can trend it, and I can see that that trend is clearly, you know, going upward. So let's look at its volume. So I drilled down to its volume. There's really only one volume that is busy, and the volume name is the WRHQ192_A_FCOD. It has a rating of 0.42, and what I can do is I can set a trend on that. So we see that trend is obviously not going in the right direction. We can take a closer look at it, and we can see that it's got 8 terabytes allocated from the host perspective. Within the AO policy, it's almost 8 terabytes. Most of the space is on the 450s. It has no access to SSD. So, you know, if we wanted to improve the performance of this volume, we would likely want to create maybe a new policy that had access to a CPG on SSD. So in conclusion, IntelliMagic was used to identify a bad trend. The response time for this particular volume, WRHQ182_F_A_FCOD, is trending poorly. We could do trending analysis with any metric over any time period, and we could get a good handle on whether our capacity is increasing and it needs to be addressed, or our performance is. And we can actually improve the disk response time for this volume if we want to by adjusting the policy to include some flash, or maybe if the adaptive flash cache needs more SSDs to do the work, or whatever. So in this presentation, what we did was we looked at the understood if we had enough HP. And the benefit there is if you have a system that can tell you how close you are to the edge, you can safely manage the environment. Also, we looked at knowing if your AO policy is optimized, and really that's about being practical and getting the most bang for the buck, making sure you're using the more expensive drives optimally, and maybe looking at, we didn't do it, but maybe something we could have done is look at the SKU curves and decided, hey, we really need a different mix of drives. Also, we took a look at the cost of optimization. There was actually some impacts on the front end because of the AO policy migrations, and we used vision to quickly identify the bottlenecks. And then we took a look at the system and front-end imbalances, and really you just want to make sure you have a quick way to see if there's any artificial constraints by a suboptimal balance. And last, we looked at trends. And some trends are okay, some trends are good, other trends are bad, and we looked at a bad trend and how we might correct it. So Anthony, that is the end of the presentation. Are there any questions?
We do have a couple. The first one here is, what if we use 3 tiers in AO? This is asked by Mike.
Okay. Well, that would be fine to use 3 tiers. The examples I gave were done for the way they originally set that up was for political expediency, meaning certain groups said, hey, we want SSDs, and we're willing to pay more for them. And the other group said, well, we're not paying more, so they got stuck with the fiber channel and nearline. So you're absolutely fine to do that. What you really want to do, and I didn't get into it too much, is to look at your skew curves and analyze your skew curves. That's something I can help you with, and try to figure out what the best configuration is for your workload. And the skew curve discussion is probably bigger than we have now, but it's something we could take offline.
Great. If you want to ask a question on your GoToWebinar control panel on the right, there is a questions field. Go ahead and send those in. Another question that has come up is more general. They want to know if we're going to be making these slides available, and the answer to that is yes. You will be receiving an email both with the slides and with the webinar recording after we are completed with this webinar today. Do we have any other questions? Give it another 10 seconds for someone to pop a question in. All right, that looks like all of our questions for today. We want to thank you for joining us. Brett, thank you very much for presenting today. We hope you all have found this webinar helpful. As I mentioned, you will be receiving an email with a link to both the webinar's recording and additional resources, and you're going to get the slides as well. You may find these additional resources helpful to optimize your HPE 3PAR environment. At IntelliMagic, we appreciate your feedback, so contact us directly via email or phone number right here on the screen. And from all of us at IntelliMagic, thanks for attending today's webinar.